In this video, we will deploy a simple app to AWS Container Service using GitHub Actions and Terraform. So Terraform is a software that can help us build the AWS infrastructure very easily using only code. So let's begin. This is a starting app. It is a simple Node.js app, but you can use any programming languages. It doesn't matter if I chose Node.js for this example. What is important here is a Docker file. Each programming language that you will use will have a different Dockerfile configuration. If you don't want Node.js and you want another framework, you can check my other videos where I deploy different apps. For example, here in Golang, in Svelte, Django, C#, and Kotlin. So you may check my other videos on how I configure the Docker file. So this is the only difference regarding the Docker file. Everything else will be the same. So the first step now is to share the project on GitHub. So I created a repository and I deployed this code. So you may check the starting repo to Scalable scripts /node Terraform, and here, as you can see, we don't have a GitHub Actions setup, because in order to set the GitHub Actions, we need to set up first the AWS infrastructure. And for this, we will use Terraform. The first step here for Terraform is to install the software. It is pretty straightforward. You can install it in any of these operating systems. I did it in my machine, and let's get started directly here. So the first step is to create a Terraform file. So all Terraform files will end with a tf suffix. So the first file that we will create is called config.tf. So here we will store the credentials in order for Terraform to log into our AWS. And we don't have any credentials yet, so the provider here, so we need to write this code. AWS, we need to provide the region. In our case is US East 2, so I'll put it here, US East 2. We need a access key, which we don't have, and a secret key, which we also don't have. So where do we find this access and secret keys? So let's go to the AWS console and go to IAM. So you can go here if you have it, or you can search here directly, IAM. And here we will create a user, and that user will have the credentials that we need. So I will add a user here. I'll call it Antonio. Next. And I will attach here the policies directly. And I want the administrator access. So this is a simple demo for this app. Of course, in bigger apps, you need to restrict the permissions. I gave this user all the permissions for all the resources in AWS. So I will create this user, and I will select the user, and we have here security credentials. Go there, and we need to create an access key. So we need to select here application running outside AWS and click next. And this is optional, we don't need this. I will call it Terraform. Create access key, and we have an access key here, which I will copy. I will use it here, and a secret key, which I will copy, and I will use it here. Don't use my credentials, because once this tutorial is over, I will remove this user. So these credentials won't work. And that's it. So with this, we configure Terraform to connect to AWS, and we can try it via the command terraform plan. So we need first to run Terraform init. So this is a command that will set up all packages that we need. So Terraform init, and it will install all the packages that we need. So everything is installed and Terraform has been initialized. We can see other files that are created here. Do not touch or modify these files because they are used by Terraform. And now let's run Terraform plan, and nothing will happen here because basically we didn't add anything to the infrastructure. So let's start by creating a VPC. Let's create a file vpc.tf. So all the resources in AWS are connected to VPCs. They are the most important part of AWS. The command is resource AWS underscore VPC. And we need an address here, so I'll put this address /16. So you need to specify which block they should use in AWS. I will add also two more options here, which is instance tenancy to default and enable DNS host names to true. So this is our VPC of our app. So we don't need to go directly to AWS and create it manually. So let's go to the VPCs and let's see how many VPCs. There are 3 VPCs here. Once we start this, it will create a 4th one. So let's do it. First, let's run Terraform plan, and this will show what is going to change. We can see that we will create a new VPC. And to apply this change, we need to run Terraform apply. It will ask us if you are sure, so we will type yes here. And Terraform now, it will use these credentials that we provided in order to create this VPC. So as we can see now, it is creating. And once it is finished, we should be able to see another VPC. Let's refresh. And we can see 4. Not sure which one is the last one. I guess it should be this last one. Maybe I should have renamed it. Anyway, we created our first VPC, virtual private cloud. Now we need to add subnets. So I will add down here 3 more resources. So resource type is AWS subnet, and I will call this SN1 because we need to create 3 of those. First, we need a VPC ID, which is this VPC that we created. So my ID is helping me in this case, and we need the same for this block here. We need it here, so I'll copy this. I'll put the value 1 here, and here I'll put 24. So we need to specify values that are available in our AWS. We need also availability zone, which is US East 2A. And we need to add another option, which is map public IP on launch to true, because we need to make everything public in order to view it in an IP that we create in ECS. So I'll copy this, create subnet 2. I will create this to 2, and this is 2B here, and I'll paste it again, and this is subnet 3, this is 3, and this is 2C, I guess. And let's see if this works. Let's create also these other subnets. Now if I apply it again, it will ask me again, so I can type yes again, but I will specify here auto approve. So this will auto approve that value, and we will create directly the subnets. So we have 3 subnets to be created. Let's wait till they are completed. So they are completed, and now we need one more resource here in this VPS file, and that resource will be AWS security group. So once we create the ECS cluster, we need all these subnets and this security group. I will call this SG, and the name will be SG. VPC ID will be this VPC that we just created here. And here we need to map some ports that our security group will make them public. I will paste them directly. So we need some ingress rules, basically to open the port 80 and 443. So this is just the HTTP port, and this is the HTTPS port. So if we request this port to our VPC, we need to allow that request, basically. That's why we need to add this. And that should be it. So let's apply this again. And all this VPC part, the confusing part, which are required by AWS, are almost done. And now let's go to creating an ECS cluster. So the first step is to create a repository. So repository.tf. So here we will store the image of our app. So we need to push this image to AWS, and for that we need to create a repository. So the resource will be AWS ECR repository. I will call it repo. The name will be app_repo. I will add this image tag immutability mutable, and image scanning configuration. Here scan and push, I will make it true, and that should be it. So this is pretty straightforward. It will be the same as going to Elastic Container Registry here and just creating a new repository, which is just a few clicks, but we will do it in Terraform. So if I apply this, we will see a new repository here. So it was created. If I refresh here, we can see we have the app repo here, and it does not have any images because we need to push the images there, but we will push it using continuous integration and delivery, not via commands here. So we created the repository, and the last step now is to create the ECS cluster. So let's create here ECS.tf. Here we need to create a resource, AWS ECS cluster, and I will call it ECS here, but the name will be app_cluster. And that's it for the ECS cluster. Now the ECS cluster has some ECS services, so we need to create a resource, AWS ECS service. I'll call it service, and I will call it app service here. We need a bunch of configuration, which I will just copy them because there are a lot. And basically we need the cluster, which is this cluster that we just created. Launch type will be Fargate. We have some options here which are required, which is enable execute command, deployed maximum %, healthy %, one task. We need a task definition, which we will create now. I will comment it for the moment. And the network configuration, we will assign a public IP and we will specify our security group that we created in the VPC and the subnets that we created in the VPC. So as we can see, Terraform does not import anything, so everywhere in all the files they can communicate with each other, so we can assign them directly. What is left is a task definition, which I will also copy again because it's a lot of code. So I will create an ECS task definition. I'll call it TD here, and the container inside will have the name app. The image will be this image that we got here in the repositories. I'll paste it here. So this is the right repository for that app. We need to specify CPU and memory, essential to true, port mappings. So this is a container port. Our app will run on port 80. So when we run node index.js here, and we need to expose the port 80 as well. The family, I will call it app, and the compatibilities, it will be Fargate. And we need also these two roles in order for us to use ECS. So this is ECS task execution role. So if you go to IAM and go to the roles, there is a predefined role there, which is ECS task execution role, which is this one. So these are all the necessary configurations. We need to specify the task definition here. And what is left now is to just apply it. So I will apply it. And if we go to the container service, we should be able to see the cluster being created. So this is a cluster. Not sure if everything is created. So it will take a while until everything is created. And let's wait till it's completed. So everything is created. We can see here it has finished, and we have the cluster now with one service and the deployments that are trying to run to this app, but for sure that they won't work because at the moment we don't have any image in our repo here. And now to add images, we need to configure GitHub Actions in order for each push that we make to our app, the image should be added here and also deployed on AWS ECS. So let's see how to do that. Now let's add the configuration for the GitHub Actions workflow. So for this, in every project, it doesn't matter for the language that you choose, we need to create a directory here. I'll call it GitHub. And inside this GitHub folder, we need to create another directory called workflows. And inside this directory, we need to create two files, one YAML file, aws.yaml, and the other one is, I will add it to Git, and the other one is a JSON file, task definition.json. So let's start with task definition.json. This one is pretty simple. It has a lot of code in it, but we can find it easily by going to task definitions here. If we select up here, we have some versions for the task definition. I will select the latest one and go to JSON here. And we see a JSON here. I'll just copy it to the clipboard and paste it here. So this JSON will be this that we find in task definition JSON here. And I will make only a small change here, which I will remove this 18 here. I will always use the latest version, and I will remove the revision 18 here. And that's it. The other configurations are fine. Now we are finished with the task definition. Now let's go to aws.yaml file. Here we will start with this code. So the name will be deployed to Amazon ECS, and this is when we push to the master branch. So this could be the main branch or any other branch here. And we need to set up some environment variables. So in our case, the AWS region is US East 2. The ECS cluster is app cluster. You can find it here in the clusters. This is the name, app_cluster. The container name is just app. ECS service is app__ service. You can find it when you select the cluster. This is a service. ECS task definition. So this is the file that we just created. So I will put here .github/workflows/task-definition.json. So this is this file that we created. So we set up the environment variables, and now let's add the other part of the code. So I will paste it here, and when we deploy, we specify a name. This is the container will run on Ubuntu, and this environment is dev, so you can put whatever you want here, dev or production. This is just informational for you to know which environment is getting this change. And now we need to specify the steps. And the first step will be to check out. So this is the action that AWS uses. So every platform has their own actions. The second step is to add the credentials. So I'll paste it here. Configure AWS credentials, and this is the command that we need to use. Now we need to add the access key and the secret key here, which I will copy directly for the moment, and later on I will show you how to add the secrets in GitHub. So for the moment I will just put the values like this. So this is the access and secret key. The region is the same as this one, so we can put it like this, or we can put it as a variable like this $. We open the brackets. Inside we need to put env dot AWS region. So this is how we show that value. And this is the second step. Now let's go to the third step. So for this third step, it may be a little bit confusing. So I'll paste the code here. And we need to build the image and push it to Amazon ECR. So this is the registry. So this is where we store the images. The repository is app_repo. So let's double check in the registry. It should be, let's go to repository. So app_repo, that is the registry. The image tag is latest. So the first two commands here are pretty self-explanatory. So we build the image that is inside this Docker file, and then we push it to the ECR registry. So we build and we push the image, and we will add it here that we don't have any image. Now the third line is a little bit confusing, so we display the image name. So why do we need that? So we need that for the other step, which I will copy and paste it again here. So fill the new image ID to Amazon ECS task definition. So this will use this AWS command, and the credentials that we need to put here is the task definition, which is the environment ECS task definition, which is this file that we just copied there. The container name is the container name, which is app. So this is the environment variable that we have. And this last step is this part that we echo this image tag. So we need the latest image that was built. And once it is built, we display the image name, which we use it on the next step. So the steps here is build image. So as we can see, each step has an ID. which is build underscore image, outputs image. So we set the output here, which is image, and this is the value. That's why we added this third line. And we need one last step, which is to let me add it here, deploy to AWS task definition. So this is the command. I need to indent a bit here. The task definition is again the next step, which is task definition 1. This is a previous step. Outputs task definition. So once we fill this to the task definition, we get also the task definition ID, which we added here. The ECS service and the cluster are predefined here, which is a service up service and cluster up cluster, and white for service stability to true, and that's it. This is our code to deploy our app. Let's try it out to check if it works. So for the moment, I will just commit these files. So add, the font is really small there. Add GitHub Actions workflows, and I will push this code. So once I push this code, let's go to the repository that I have here and go to actions, and as you can see, everything changes now. So as you can see, we have one workflow that is currently deploying. So as you can see, deploying to dev. Dev here is this environment, so this is just informational. It doesn't do anything, but it's just for you to know where we are deploying. If we select there, we have setup job, checkout, configure AWS credentials, just like we did. These are all the steps. Now it is building the image and pushing to Amazon ECR. Once this finishes, in the ECR registry, we will see another image here, which hasn't been finished yet. And then after that is completed, it will assign it to this service, which we have a task that always fails. We need a task that works. So let's wait till this is completed. So it seems that it failed, and when we see the message here, it says somewhere here, no basic auth credentials. So the reason that we get this error is that I made a mistake. I forgot one step, and I will add it here. After we configure the AWS credentials, we need to log in to Amazon ECR. So this is a step that I forgot, and this will work now. It will not fail. So let's commit it again. I'll have the same message. I'll push it, and let's wait till it's completed. A new workflow will be created. So the first two failed, and let's wait till this is completed. So it failed again, but now there is another reason. It says that our user has not is not authorized to perform an action to this resource. But as we can see here, we successfully logged in. We build the image and push it to ECR. So if we go to the ECR here, I will refresh here. We should be able to see an image which was pushed. So we successfully pushed the image here, and now let's find out why our user does not have those rights. I will go to IAM, and not sure why AWS adds for each user this AWS compromise key quarantine v2. So the solution that I found here is just to remove this permission here. Just add the administrator access and everything will be all right. So we can push another image, or we can simply rerun the previous one. So let's rerun all the jobs here, because we haven't made any change to the code, and let's see if this will be successful now. So I got stuck at this step, so I deployed a lot of times, but they never succeeded. And it seems that it is stuck on this deploy ECS task definition. So the mistake that I made was this one: wait for service stability, which is true. I'll make it false, and I will commit it. Change to false, and this will work. But why is our service not stable? So I did that on purpose because there are also some other changes that we need to add to Terraform. But first, the first change that I need to add is this secret and access keys. So I will cancel this workflow. And we have another workflow here, but this one will work. If we go to settings and go to environments, I added them before, but I can update them. So in the environment secrets, we can add the AWS access key ID. I'll edit and I'll put this value. And instead now we can add here this code, which is $secrets dot this value, which is this one. So this is how we protect our secret keys. Let's do the same for the other key, which I will copy and paste it here. Save it, and I'll do it the same. This one is AWS secret key. Okay, this one is fine till now, but what is the problem? That our task definitions are not starting. So if we go to our ECS, we see that all the tasks that we have, they are not working. The reason is we need more configuration regarding the VPS side. I didn't want to add it in the beginning because there is also more code and it can be more confusing. But in case you have this error, this will be the solution. So before I add the code here, if we go to the actions, we can see that everything is successful. So our GitHub Actions has worked till the end. However, our ECS is not deploying the tasks, and I will solve the problem now. What we need is an internet gateway. So instead of, I will add here resource AWS internet gateway. I'll call it gateway, and we need here the VPC, which is our VPC. So that's it. We need to configure a route for each gateway. So we need a table here, resource AWS route table, and I'll call it RT route table. We need to specify the VPC, and also we need to specify two routes. One is CIDR block, which I'll put 00, so I'll give access to all of those. Gateway ID is this ID that we just created here, so it is AWS internet gateway gateway.id, and we need another route here, and this time is IPv6, and the value here will be just like this. So I will give access to all the IPs. So we created a route table, and now we need to add the mapping to from our subnets to this route table, and we will add the resource AWS route table association, and this is route 1. And for the route table ID, we need AWS route table. AWS route table ID, and we need the subnet ID, which is AWS subnet1.id, and we will do the same for all the other subnets. So this is the part that was missing. I did it on purpose, that I knew it was going to fail, but this is not intuitive at all. So you may have this problem, and I had to show you that we had an error, but we didn't know the reason. That's why I give you also the answer. So in case you are stuck, maybe this video can be helpful to you. And that's it. This was the part that was missing, and I will apply auto approve again. And once everything has finished, so the maximum number of internet gateways have been reached. So it seems, let me go to internet gateway. Here, let me remove the others because I don't use them. I will delete internet gateway here. Not sure why the others are like this, so I will delete all of this. Maybe I just wanted to delete one. Let me do it again. So it seems that it worked. We can see now that we have created another internet gateway, and everything should work fine. Let's go to the Elastic Container Service, and I'm sure this time we will see the cluster working, and it is running successfully. Now to see our app, go to app service here. Let's see our task. This is our task. I will select it, and this task has a public IP. Not sure where do I see it. So tasks here. Here is the public IP. If I open the public IP, you can see there hello world. So it is working. Now let me make another change. I will just rename this to hello world 2, just to show you that this works. And also I will change this wait for service stability to true now, because for sure everything will work fine. And change hello world, and when I push, we will see that in Github Actions everything will be deployed, and a new image container will change here. So let's wait till everything is ready. So everything works fine. As we can see, it was successfully deployed, but there is one thing. If we go to this URL, probably it won't work, and it won't work if I refresh. The reason is because another container has taken its place, and it is another public IP. So this is a new IP, and if I go there, is hello world 2. So everything is working fine. The only problem is that the IP changes every time that we make a deployment, and I will fix this in the next tutorial, not in this tutorial. This tutorial was focused only on deploying with Github Actions to Amazon ECS. And in the next tutorial, I will add more stuff to this app that we deployed, like a load balancer and maybe some CloudWatch events. So, thank you for watching. Don't forget to like, share and subscribe. Thank you.